Alright, so we're going to start the chapter 4 test review part 1. So let's look at this first one. It says the line containing AC, so this line, is called the blank of BD. So we need to see what AC is doing to BD. And if we look at BD, they each have one tick mark. That means that this AC is bisecting it. And not only is this AC bisecting BD, it's also bisecting it at 90 degrees. So we call that a perpendicular bisector. Okay, do not get it confused. Okay, AC is the perpendicular bisector of BD, but BD is not the perpendicular bisector of AC. Okay, so that's important to understand that because there's no tick marks here, right? All right. So use the figure to the right to find the length of DC. So remember the perpendicular bisector theorem, which tells me that if I have a line segment that is being bisected perpendicularly, that means that the endpoints of that segment, let's say segment AB, the endpoints of the segment that is being bisected is going to be equidistant to any point on the perpendicular bisector. So we have 2 points here on the perpendicular bisector. This distance and this distance are going to be the same. And if it was this one, they would be equidistant as well. So if we take a look at DC, put a different color. If we take a look at DC, we can see that DC is equidistant to the angle bisector. What is the angle bisector? I mean, the perpendicular bisector. So this is the perpendicular bisector. So that means that a point on the perpendicular bisector, D and B, is going to be equidistant to A and to, is going to be equidistant to A, and it's also going to be equidistant to C. So that means this length and this length are the same, this length and this length are the same. So if BC is 17, that means DC must also be 17 as well. So it's the same thing for the angle bisector, right? So if I have an angle bisector, any point on this angle bisector, which is going to always be a ray, this point right here, this angle bisector, any point on this angle bisector is going to be equidistant to the sides of the angle. This is the side of the angle, and this is the other side of the angle. It's going to be equidistant to it at a perpendicular angle. So that means this distance and this distance are equal. And if we see here, FD is 12, so that means DG is also going to be 12. EC is 15, so EB is also going to be 15. Okay. Oh, they didn't even ask us that, but just in case they did, now we know for the next couple questions that this is going to be 12 and this would be 15. And we call this ray AE the angle bisector. And the angle bisector can only always be a ray. It cannot be a segment or a line. It has to be a ray. So ray AE is the angle bisector of angle BAC. BAC. Okay. Once again, here we go. It's asking us for the length of TK. So if DT is 24, TK is also 24. How do we know that? Because this ray CS is an angle bisector because of these two arcs right there. So 24. Okay. So use the figure to the right to find the length of UW. So where's UW? UW right here. So we see that this UW has one tick mark. What else has one tick mark? This 88. So this is also 88. Okay? And notice how this W can be considered an angle bisector right here. And if it, wait a minute. Okay. Yeah, no, I was overthinking it. It's just 88. Tick mark, tick mark. Okay. So, okay. The reason I don't like this question, URV, okay, they want us to know that this, hold up, this angle UWV is an angle that is being bisected. How do I know that? Whoops, sorry. This URV angle is being bisected because a point on this angle bisector, the highlighted one, a point on this angle bisector, we're going to call that point W, is equidistant, is it not? Look, this W, a point on this angle bisector, is equidistant, right? You see the one tick mark, to the two sides of your angle. The reason I don't like this question is because this does not look like an angle bisector, and this does not look like an angle because it doesn't have these little arrows. But you need to understand that this is just an angle that's being bisected because the sides that are connecting the sides of the angle are equidistant to a point on the angle bisector. This RW or RZ is supposed to be counting as the angle bisector, but it doesn't look like it because we don't have a ray. So I don't really like this question, but the whole point is that if this little piece is 70, that means that this little piece is also going to be 70 degrees. So now they're asking what is the length of angle URV? URV, so this whole angle is just 70 plus 70, which is 140. Okay, so if we take a look at this question and try to not just copy the answer, right? That's going to be pretty boring. Okay, so let's cover it. Let's look at each one. The figure shows blank. So what is this figure showing? This figure is showing an angle, right? Look, this angle QMN, that's being what? It's being bisected, right? How do I know that this angle is being bisected? They don't have the little arc in the little arc. They don't have the little arc in the little arc, right? But we know that if this angle has a point on an angle bisector that is perpendicularly equidistant to the sides of the angle, then that means that these two angles must be congruent. So that is why this ray MR is considered the angle bisector of QMN, angle QMN. So let's read this. So look at A. The figure shows an angle bisector, right? There is no perpendicular bisector. There's not. So when we see here in the options, is it a perpendicular bisector or an angle bisector? We know perpendicular bisectors are only found in segments. Wow, that was really bad. In segments, right? Angle bisectors are found in angles. Okay? So every point, this figure shows only an angle bisector. What is the angle bisector? Look here. What is the angle bisector? The angle bisector is ray MR. So ray MR is the angle bisector of what angle? We could say angle QMN or NMQ. They decided to use QMN. Every point that's on the angle bisector is equidistant from the angle sides of the angle, right? So this would be QM and mn. So let's see, every point on ray mr, it should be ray mr, which it is equidistant from angle sides qm or mq, mq, and mn. And the next question is very similar, right? Okay, so we have a segment that is being perpendicularly, right? Perpendicularly bisected. So this figure shows a perpendicular bisector. Blank is the perpendicular bisector of blank. So what is the perpendicular bisector? What is the thing that is bisecting something? The thing that is bisecting is this line CD. So line CD, notice this is line, the little dash with the two arrows on it, is the perpendicular bisector of segment AD. Segment AB, AB. I meant to say AB. Every point on the angle, the perpendicular bisector, it's equidistant to the points at the end of the segment that's being bisected. So every point on line CD is equidistant from points A and B. Okay. So what is the value of Z? So if we look here, we see that we have a perpendicular, right? A perpendicular bisector. So if we have a perpendicular bisector, that means that we're going to have any point on this perpendicular bisector, let's call it point M, is going to be equidistant to the endpoints of the segment that was bisected perpendicularly. So that means that this 16z minus 24 is equal to this 4z. So 16z minus 24 is equal to 4z. So minus 16z minus 16z negative 24 is equal to negative 12z. Divided by negative 12 divided by negative 12. Your z is equal to 2. Okay. Same thing here. I have a ray that is bisecting. How do I know that this is an angle bisector? Because I don't see the little arcs, but I know that if a point on an angle bisector is equidistant and perpendicular to the sides of the angle, that I have an angle bisector. So that means that this 5y and this 2y minus plus 18 are equal. So 5y is equal to 2y plus 18 minus 2y minus 2y. 3y equals 18 divided by 3 divided by 3. Y equals 6. Y equals 6. Okay. Once again, same thing. I have an angle bisector, so that means that this side and this side length are equal to each other. So 4y is equal to 2y plus 4. So minus 2y minus 2y. 2y equals 4. Divide by 2, divide by 2. So y is equal to 2. Now we see here it says y is equal to 2. So in order to find ST and TU, we just have to plug it into one of them. Why only one of them? Because if ST is 8, which it is, because what is 4 times 2? Then that, if this is 8, that means TU also must be 8. So 8 and 8. Okay. Okay. Now I see that I have a segment that is being bisected. So if this segment is being bisected perpendicularly, then that means that any point on this perpendicular bisector, let's call it W, is going to be equidistant to the endpoints of the segment that it bisected. So this 4x is equal to this 6x minus 6. So minus 6x minus 6x. Negative 2x is equal to negative 6 divided by negative 2. X is equal to 3. So now, if x is equal to 3, they don't actually want x, they want TW. So I'm going to plug it into TW. So what is 4 times 3? That is 12. Okay, so here I have the dreaded 2-column proof, right? So if we did this from scratch, let's start. Okay, let's start with this first one. Line PM bisects AB. How do I know that? It's given. It's right here, up here on the given. So given. Now, AM is congruent to BM. So where's AM? So AM is over here. AM and BM are equal. How do I know that they're equal? Well, I know that they're equal because this PM is bisecting them. So if segment AM and segment BM are congruent, then that means that something had to have bisected segment AB, this whole segment. So definition of bisector. Now, how do I know that line PM is perpendicular to the segment AB? Because they said it, so it's given. Now, how do I know that PMA and PMB are right angles? Because that's the definition of perpendicular, right? If something is perpendicular to something else, that means what's going to form are right angles. So definition of perpendicular. Now, how do I know that angle PMA is congruent to angle PMB? Well, if angle PMA and angle PMB are right angles, then that means they're both going to be what? 90 degrees. That's what it means to be a right angle, is that you're both 90 degrees. So all right angles are congruent. Now, segment PM is equal to segment PM. That is reflexive property. Now, we have a triangle congruency. So I should have been this whole time putting in what I know about this triangle. Well, there's only one thing that they did. There's only one thing that we had to do that they didn't already do for us, right? They already put the tick marks here. They already put the right angle. We just had to have put this part because of the reflexive. So what type of how are these two triangles? How is this triangle AMP and BMP congruent? Because of SAS. So it should be SAS. And now, how do I know that segment AP is congruent to segment BP? Because of CPOC-TEC. Okay. So the exact same thing here. Let's cover these up to make it more challenging, right? Okay. So let's look at the first one. Ray QS bisects angle PQR. So PQR is being bisected by ray QS. Okay, that's given to me. It was right here. It's given to me. Now, how do I know that PQS and RQS are congruent? That's the definition of a bisector, right? The fact that now this one big angle is being split into two congruent angles. So definition of angle bisector. Now, how do I know this stuff? In step 3, it's right here on the top. So it's given to me. Now, QPS, angle QPS, and angle QRS are right angles. How do I know that? Because that is the definition of perpendicular. Again, if two things are perpendicular, then that means that those two rays or lines or segments are forming 90-degree angles. And once again, we know that QPS and QRS are both right angles. So all right angles are congruent. Now, how do I know that segment QS and segment QS are congruent? That's reflexive property. So now they ask us a triangle congruency question. So that means I'm going to need a postulate. So let's see if there's anything else that we could have done. So yeah, the only thing they did for us was that I have a 90 degree here and a 90 degree here. Okay, so Look, step 5. Angle QPS, and QRS are both congruent. Okay, I already did that. Okay, what else? What else do I know? Oh, right here, step 2. Look at step 2. PQS, and RQS are congruent. So they already did that for us. So the only thing that we had to do was this QS right here. Now, we know that this is not ASA. Why is it not ASA? Because for ASA, this S has to be included between the two angles. Is this tick mark included between these two guys? No, it's not. If it was included, the tick mark would be here, but it's not. So this is AAS or AAS. AAS. And now, once I prove that two triangles are congruent by a postulate or theorem, this is a theorem, I can then say that segment SP is congruent to segment SR because of CPOC-TEC. Okay. So now we're starting 5.2, which is all about the circumcenter and incenter for 5.2. So let's look at this first question. When 3 or more lines intersect at one point, the point of intersection is called the point of concurrency. Remember the mnemonic device, because it's going to be pretty helpful. All of my children are bringing in peanut butter cookies. So this A stands for altitudes. And altitudes, the point of concurrency of altitudes is the orthocenter. Now, this M stands for medians. Your point of concurrency of medians is your centroid. This AB stands for angle bisectors. And your angle bisectors is the point of concurrency of your incenter. Now, this PB stands for perpendicular bisectors, and your perpendicular, the point of concurrency of perpendicular bisectors is your circumcenter. Okay. So when 3 or more perpendicular bisectors of a triangle intersect at one point, that is called the circumcenter. We just did that in the previous one. Perpendicular bisectors is circumcenter. Okay, so a triangle's circumcenter is outside the triangle in obtuse triangle. So just remember, when your circumcenter of a triangle is inside the triangle, that is an acute triangle. When it's on your triangle, it is a right triangle. When your circumcenter is on the triangle, that means that triangle is a right triangle. Where specifically is that circumcenter in a right triangle? In the midpoints of your hypotenuse. And when your circumcenter is outside of your triangle, that triangle is an obtuse triangle. So obtuse. Okay. Okay, a triangle's circumcenter is on the triangle. When is it? When it's a right triangle. We just did that one. Okay, what about this one? Can be inside, on, or outside the triangle. We just did that. We just did when the circumcenter can be inside, it's acute, on its right, and outside is obtuse. So why is it not incenter? Guys, remember, an incenter looks like this. Right? Because the circle is inscribed your triangle. A circumcenter looks like that, where the circle is circumscribing your triangle. So when your center is circumscribing the triangle, that circumcenter could be here, in this case for an acute triangle. It could be here in the case of a right triangle, which is on it. And if it's an obtuse triangle, whoops. it can be outside. That's a really bad example. That was terrible, actually. That's probably a little bit better. It's going to be outside of your triangle and obtuse. However, in an incenter, because of the fact that your circle is always going to be inside of your triangle, that means, guys, if the circle is always inside the triangle and your center of the circle is obviously always inside your circle as well, then if the circle is inside and the center is inside of that, how can this center ever be outside the triangle? It's never going to happen. That doesn't make sense. So that means even if it's an acute triangle, a right triangle, or an obtuse triangle, your center will always be inside the triangle here. The only time when your point of concurrency can be in, on, or outside is for circumcenter. If you guys know 5.3, you should be able to tell me when the point of concurrency can also be inside, outside, or on your triangle. There's another point, right? So if you guys know it, good. If not, we'll just get to it when we get there, okay? So for now, between incenter and circumcenter, the only time when your point of concurrency, incenter or circumcenter, can be in, on, or outside the triangle is for circumcenter. Okay? Now, center of the circle that passes through the vertices of the triangle. That saying, given the following statement, determine to which points the statements apply. So, center of the circle that passes through the vertices of the triangle, that is going to be your circumcenter. Because in this triangle, we can say that these are the vertices, and we know that the invisible circumscribing circle will always pass through the vertices of the triangle. And when it's a circumscribing circle, that's when we have an circumcenter. Circumcenter. So that's why the answer is circumcenter. What about if the circle passes through the perpendicular sides of your triangle? What is this called then? It's called an incenter. Okay, so let's see if the next question has something like that. Center of the circle that touches each side of a triangle only once, that's an example of your incenter, the one we just did. That's when it's an incenter. Okay, now this is exactly, wow, this, man, when I was making your test, this looks so familiar. I wonder if this will be on the test, who knows? All right, so point O is the blank. So let's look at point O. Point O, it looks like there's 3 segments that are meeting at point O. I have OJ, I have KO, and I have LO. These segments are all called perpendicular bisectors. Why are they called perpendicular bisectors? Because this is forming 90 degrees and it's also bisecting. This is forming 90 degrees and it's also bisecting. This is forming 90 and is also bisecting. That means that KO, OJ, and OK, OJ, and OL are all perpendicular bisectors. And what is this point if it's the point of concurrency of perpendicular bisectors? That is the circumcenter. Okay? And we know that the circumcenter is equidistant to the vertices of the triangle because of the invisible circumscribing circle. So that means if OI is 26, then what is OG and OH? They are also going to be 26. This 6 is just here to confuse you. Once again, the only reason we care about the perpendicular bisectors is so that we can find our circumcenter. We do not care about the length of the perpendicular bisectors, just like how we do not care about the length of the angle bisectors for an incenter. Okay, we do not care about this 6. This 6 is useless. So the answer should be circumcenter and 26. Okay, OG is 26. So, point P point P is the incenter. So why is point P the incenter? Because what three lines are creating this P? It is this angle bisector, this angle bisector, and this angle bisector. And what is the point of concurrency of three angle bisectors? That is the incenter. Incenter. And we know that the incenter is equidistant to the perpendicular sides of your triangle. Why? Because there is an invisible inscribed circle there, which just become what? What is this and this become? They just become the radius of this inscribed circle. Just like how for the circumcenter, they became the radius of the vertices of the circumscribing circle. Okay? So that means, so if P is the incenter, then that means that this and this are all congruent. So that means if PB is 4, what is PC and PA? They're also 4. This 26 is just there to confuse you. So the answer is incenter and 4. Okay, I'm gonna drink water. So give me like 10 seconds. Okay, so this question 24, I'm gonna go more in detail in class, but just letting you guys know that this triangle is a right triangle. You guys are just used to seeing right triangles look like that, but this triangle is actually a right triangle right here. And the reason we know that is, I'm gonna go over it in class because I don't wanna go over it here. So remind me to do question 24. Okay, so because we know that this, well, we should know, we're going to know that this is a right triangle. So if this is a right triangle, with this being the 90 degrees, then that means that this side is the hypotenuse. And if this side is the hypotenuse, what do we know about the circumcenter of right triangles? They're always on the midpoint of your hypotenuse. So let's get the two endpoints of this hypotenuse. This point and this point. So this looks like -10, 0, and this point right here is 8, 0. So we know that we don't really need to worry about these y's because it didn't change. So that means that this midpoint is 0. But in case you don't see that, let's just do the midpoint formula. Okay, so now let's call this x1, y1, x2, y2. So what is -10 plus 8? That is -2 over 2, which is just what? So this is -10, this is 8, so what is -10 plus 8? That is -2. What is -2 divided by 2? That is -1. Now, for the y, what is 0 plus 0? 0. What is 0 divided by 2? 0. So my circumcenter is -1, 0. Okay? So, find the coordinates of the circumcenter of triangle ABC. So when you see a question like this, you should draw it, okay? So if we see this question, we're gonna draw A is 0, 0, B is -5, 0, and C is -5, -6. Now, for those of you that can already kind of see where this is going, even without drawing it, which is great, is that there's a right triangle. How do I know that this is a right triangle? Because if I look at these coordinates, this coordinate and this coordinate share the same x. So if they share the same x coordinate, that means it is going to be a vertical line, a vertical segment. And look at that, it is. Look, you guys see how there's a vertical segment? Now, let's look at A and B. A and B both share the same y coordinate. So when they share the same y coordinate, that's going to be a horizontal segment. And look at that, it is A and B. So what do we know about a horizontal segment and a vertical segment? What do they create? 90 degrees. So now this AC is the hypotenuse. So we just have to find the hypotenuse of this AC. So that we don't have to write our formula again, we're just going to do x1 plus x2 divided by 2, y1 plus y1 divided by 2. So what is 0 plus negative 5? Negative 5. What is negative 5 divided by 2? That is negative 2.5. What is 0 plus negative 6? That's negative 6. What is negative 6 divided by 2? Negative 3. So my circumcenter is negative 2.5 comma negative 3. Okay. So what about this one? Okay, so name the point of concurrency of the angle bisector. Okay, so I just need to figure out the point of concurrency. The point of concurrency is what? Where three lines meet. So I have to figure out where all three angle bisectors meet up at. So let's look at the angle bisectors here. So I have one angle bisector. Wow, that looks so confusing. Oh, okay, it's right here, I see it. So this CZ is one angle bisector. This XZ is the other one. And this YC is the other one. So where do they all meet up at? Point C. So point C is the incenter. Point C. And the point of concurrency of angle bisectors is the incenter. Okay, so find the value of x. Okay, so if we take a look at question 27, okay, what is the value of x? Okay, well, it's pointing to this segment and this segment. So I have to figure out what is special about this segment and this segment. Well, I can see that this, whoops, okay, I can see that this and this are two angle bisectors and they meet at one point. So when this angle bisector and this angle bisector meet at one point, what is that called? That is called the incenter. Now, I know that the point of concurrency is supposed to be 3 lines, but it can be 2. That's okay, it can also be 2 because we know that if this B was bisected, it would also go to there. Okay, so if I know that this point is the incenter, then that means that these perpendicular segments that I have there are all what? They're all congruent. Because I know that the incenter, let me erase all this. I know that the incenter, this point, is equidistant to the perpendicular sides of the triangle. And if I know that this perpendicular side is 7x minus 8, and this perpendicular side is 5x minus 2, I know that both of these perpendicular sides are congruent, and if segments are congruent, then their values are equal. So I just have to set 5x minus 2 equal to 7x minus 8. So minus 5x plus 8 plus 8. So, whoops. So negative 2 plus 8 is 6. 7x minus 5x is 2x. So divide by 2. Divide by 2. X is equal to 3. Okay? So x is equal to 3. Now, I love this question. Okay. Let's erase some of this stuff here. Okay. You are trying to talk to a friend on the phone in a busy bus station. The buses are so loud that you can hardly hear. Referring to the segment at the right, should you stand at point P or point C to be as far away from all the buses? So, I want to be as far away from all the buses as possible. So if I had a point right here, I'd be super far away from this side and super far away from this side. But I'd be
right on this side, so that's not gonna work. So I want to be equally as far away from every single side possible. So that means that I want to be equidistantly away from where? From the sides of the triangle. What is that called? What is the point where I'm going to be equidistantly as far away from all the sides of the triangle? That is called the incenter, right? So I want to be as far away from this side as this side and this side, right? So if I have an incenter, then that means I'm as far away from this side, and this side as possible at perpendicular segments. So I want to find my incenter, correct? Because my incenter is always going to be equally far away from the sides as possible. And where are the buses? On the sides of the triangle. So what is my incenter here? Well, I know that my incenter is the point of concurrency of angle bisectors. So where are my angle bisectors? I have one here and I have one here. So what does that make point C? That makes point C my incenter, and that's what I want. I don't want C. And I want you guys to look at this because this is very confusing, because what did I just say? We want to be as perpendicularly equidistant, right? So this looks like, look, Mr. Perpendicularly, a perpendicular segment. There's a perpendicular segment right here. Isn't that what incenter is? Aren't we supposed to have this like you said? Yes, but take a look at this perpendicular segment in quotation marks. I'm doing quotation marks with my fingers. This is not a perpendicular segment. This is a perpendicular bisector. I don't want that. If this is a perpendicular bisector, that means that this is the circumcenter, and I don't want the circumcenter right now. I want the incenter. So where am I going to stand to be equally as far away from all the sides of the triangle, all the area where the buses are? I'm going to be at point P and point C. Point P is the incenter. So you should stand at point P, which is the incenter, because it is equidistant from the sides where the buses are parked. So that's a good question. Okay, so this is a tricky one. Not this one, but the next one. The next one's tricky, but we're going to do both of them. This one's the easier version. Okay. So, in the diagram, which is now drawn to scale, G is the incenter. Okay, right there you guys need to start being able to think as you read. If G is my incenter, then that means that this GE, GF, and GD are all what? They have to be angle bisectors. Because I know the incenter is the point of concurrency of angle bisectors. Okay. And measured DEF is 66. Okay, so where's DEF? DEF. So that means this whole thing is 66. And if this whole DEF is 66, and that means this little piece must be 33, and this little piece must be 33. Okay, cool. That's all I know so far. Find the measure of GEF. So where is G? GEF. GEF. Boom, right there. Look at that. I already found my answer, and I haven't even really thought about the answer yet. I've just been writing what they give me. And writing what they gave me already gave me the answer. It is 33. Okay, so now this is the harder one, this one. Okay, so once again, let's try to write information we know as we read. So in the diagram, which is now drawn to scale, G is the incenter of DEF. So if G is the incenter, okay, G is the incenter, so that means I once again have angle bisectors. Okay. So measure DEF is 72. So DEF, this whole big angle, is 72, which means that this must be 36 and this must be 36. Okay. Oh, okay, whoa, what is all this? measure EFD. So where's EFD? EFD. Okay, so this really big angle is 2 times the measure of EDF. So where's EDF? EDF. Okay, so that means that this EFD, let's call, okay, in green, we're gonna color code this to help us. So EFD, which is this green color, EFD is this entire angle. This entire angle is 2 times the measure of this red one, EDF, of this one. So I don't know the measure of EFD, the green one, or EDF, the red one, but I do know that they have a relationship with each other. So in order to find the relationship of all of them, I cannot just keep saying EFD and EDF. I need to give it a variable. So I'm going to give it a variable of X, because when I give things a variable, I can more easily solve for it in that way. Now, when I remember a while ago when I told you guys, when you're assigning variables to something, you should honestly always assign them to the smaller of the angle or the segments. So what is smaller, EFD, the green one, or EDF, the red one? Well, if EFD is equal to 2 times EDF, then which one has to be smaller? The EDF, because it takes 2 EDFs, the red ones, to make 1 green one, the EFD. So let's make the measure of EDF X. So EDF is X. Now, what's the problem if we were to make this X? It would get a little bit confusing, right? Because if this whole angle was X, then wouldn't this be half of X and half of X? I do not like to use fractions. So what is a variable value that we can give EDF, this red one that we're highlighted right here? What is a value that we can give this whole angle so that when we bisect it, we only have 1x instead of half x? Well, we would have to give this whole EDF a value of 2x. Because if this whole EDF had a value of 2x, then that means that this little piece would just be x and this little piece would just be x as well. Now, if this EDF has a value of 2x, then I'm going to change the color. Then what is the value of this EFD? Well, I know that EFD, right, is equal to 2 times the measure of EDF. And what did we just give the value of EDF? We gave it 2x. So we're going to have to substitute this 2x for EDF. So what is 2 times 2x? Well, that is 4x. So now, if this whole EFD is 4x, then what is each angle that was bisected? Well, what is 4x divided by 2? 2x and 2x. So now, in order to find the value of x and subsequently find the value of this whole angle and this whole angle, I'm going to have to use the triangle angle sum theorem. So I'm going to get x plus x, which is just what? 2x. I'm going to get 2x plus 2x, which is 4x. I'm going to get 36 plus 36, which is 72, and equal all of that to 180. So now, what is 2x plus 4x? That is 6x. Okay. Minus 72. Minus 72. 108. And now, divide by 6. What is 6 divided by 108? 1 minus 6, 4. 18. So x is equal to 18. So now, I don't want the value of x. I want the value of FDG. So what is FDG? FDG. So the value of FDG is actually x. So what is the value of x? 18. So my answer should be 18. This question is very hard, and this is a typical ELC question. So in class, if you want to go over it, we can, and that's okay. All right, so let's continue, and remind me to do question 30 if you guys want in class, because I know that one's tricky. All right, so find the value of x. Well, we know that this, we have a perpendicular bisector here, so that means this length is going to be equal to this one. So we just set them equal to each other. Okay, so now we're going to start 5.3, which 5.3 we started learning about medians, which give us our centroid, and we learned about altitude, which give us our orthocenter. So the perpendicular segments from a vertex of an angle to the line containing the opposite side is called an altitude. And we know that from the vertex to the midpoint, from the vertex to the midpoint of the opposite side is the median. So right now they just talked about altitudes, okay? Right here, a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side is called the median of the triangle. Okay. The point of concurrency of the medians of the triangle is called the centroid. The point of concurrency of the altitudes of the triangle is called the orthocenter. Oh, look, that was the next one. Orthocenter. Okay. So now let's look at this one. Okay. In triangle DEF, C is the centroid. Okay, so C is the centroid. So if C is the centroid, then that means I have 3 medians. And what do I know about medians in a triangle? I know that these medians, let's take EC as an example, EN as an example. This median is split up into 2 portions. I have a 2/3 portion and a 1/3 portion. The 2/3 portion is from the vertex to the centroid. Oh, let me write this down. This is the centroid. So from the vertex to the centroid is 2/3 of the median. From the centroid to the midpoint of the opposite side is the 1/3 portion. So if CM, right, CM is 22, so see, oh, they're doing another one. All right, that's fine. So, all right, let's erase this because they're telling me that CM is 22, okay? So CM is 22. Find DC and DM. So they want DC and they want DM. This whole thing. Okay. So I know that this median DM, this big one, DM, is the whole median, right? And I know that from the vertex to the centroid is how much? 2/3 of this whole median. 2/3. And that means that this C to this M must be the 1/3 portion. So if the 1/3 portion is 22, what is the 2/3 portion going to be? It's just this 22 times 2, which is 44. And now the whole median, the DM, is going to be 44 plus 22, which is 66. So my answer should be 44 and 66, and it is. Now let's look at this one. Okay. For triangle DF to the right, is the red dashed segment an altitude, median, or neither? So let's take a look at this. Okay. So where is this red dash starting? It's starting at the vertex. And where's it ending? Okay, it's ending at this point. What do we know about this point? This point is the midpoint, actually. How do we know that? Because I know that this segment DE was bisected. And if a segment was bisected, that point where the bisection occurred is called the midpoint. So what do we call a line or a segment that starts at the vertex and ends at the midpoint of the opposite side? That is a median. So the answer is a median. Notice, look, they have two answers, so don't get confused. You have to read it. Median because it connects the midpoint of a side. No, that is not the definition. It connects a vertex to the midpoint of the opposite side. That's the definition. So your answer is D. What about here? For triangle ABC, BC is a median, altitude, or neither. So let's see what BC is. Okay, BC. Okay. Well, BC is neither, right? Because BC is one vertex of the triangle to the other vertex of the triangle. That's neither. Okay, so the answer should be neither. Okay, let's take a look at some examples, other stuff. Okay, so what would BQ be? BQ would be a median, right? Because I'm starting at the vertex and ending at the midpoint of the opposite side. What about if they asked us for AP? You guys might think that that's an altitude, right? Because you see this perpendicular. But did it form a perpendicular or did it just cross a perpendicular? It just crossed it. So that is not an altitude. This is once again a median because we're starting at the vertex and going to the midpoint of the opposite side. Where would my altitude be? My altitude would be CA because it started at a vertex and went to the line containing the opposite side. What is the opposite side of angle C? It's AB, and it's touching perpendicularly right here. So this is an altitude. What's the other altitude? BA, because once again, it starts at a vertex. What's the opposite side of angle B? AC, and it's going towards AC, but in what direction? At a perpendicular. So these would be altitudes. Okay, so the answer, the original answer was neither. Okay, what about this one? If AK is 21, so AK is 21, what is KP? All right, so they want this guy right here, this value right here. Well, let's take a look at the whole line. This whole segment is the what? This is a median because we're starting at a vertex and we're ending at the midpoint of the opposite side. So that means this whole thing is a median. That means what is a median split up to? It's split up into a 2/3 portion and a 1/3 portion. So we know that the 2/3 portion is 21 and I want to find the 1/3 portion. So in order to go from a 2/3 portion to a 1/3 portion, I have to divide by 2. Because if we do 2/3 divided by 2, which when we divide fractions, right, we just multiply by the reciprocal, we will get what? 2, 6, which is 1/3. So that means in order to get this 1/3, I need to divide 21 by 2. 21 divided by 2 is equal to 10.5. So that means this KP is 10.5. Okay. Use the diagram to the right to find the length of PD. Okay, so PD right here. Point P is the centroid. Okay, so if point P is the centroid, then that means that this BD is an entire median, and this PB is the 2/3 portion, which means that this DP is the 1/3 portion. So once again, in order to find PD, I just need to, which PD is the 1/3 portion, I need to take that 72, which is the 2/3 portion, and divide by 2. What's 72 divided by 2? That is 36. So the answer is 36. Okay. Let's take a look at this one. Name the centroid of the triangle shown to the right. So in order to find the centroid, I'm going to have to find all 3 medians. So I see my first median right here. Okay. Where's my second median? Right here. My third median? I don't have a third median. Look. There's nothing coming off of this. So now I just need to find the point of concurrency of the orange line and the green line, which is what point? H. So my centroid is H. Name the orthocenter to of the triangle to the right. So in order to find my orthocenter, I need to find all my altitudes. Once again, I know altitudes start at the vertex, so let's look at S. This line, is it gonna make 90? Yes, it is. So it's just a coincidence that it bisected. It does not have to bisect. That was just a coincidence because of the triangle that we have. So, funny enough, not only is this an altitude, it's actually also a median as well, which is pretty cool. It's both. Because this is a median because it starts at the vertex and goes to the opposite side at the midpoint. And it's also an altitude because it starts at the vertex and goes to the opposite side at a right angle. That's pretty cool. Okay, so that's one altitude. Look at T. Oh, there's the other altitude because I form a 90. And now Z, there is no altitude because it's just a midpoint. So I'm not even going to count Z. So where do these two blue lines intersect? Point V. So my answer is V. Use the figure to the right, name an altitude in this triangle. So let's look at an altitude. What, guys, if we want to find an altitude, we need to look at the right angle. So if we look at this right angle, I see what is the line connected to this right angle? Line CL. So my answer is CL. Segment CL. Good. Okay, now, orthocenter. Find the orthocenter of this triangle. So if we draw this, we're going to have 0, 0. We're going to have 6, 0. And we're going to have 6, 5. Now, for those of you astute people, we could already tell that these coordinates was going to give me a right triangle because I have two coordinates with the same x, so that's a vertical line, and two coordinates with the same y, which is a horizontal line. So I would have a right triangle, which I have right here. And we know that the circumcenter of a right triangle is the midpoint of the hypotenuse. But the orthocenter of a right triangle is the vertex which contains my right angle. So what vertex contains my right angle? B, angle B, which is 6, 0. So my orthocenter is 6, 0. Okay. 45. Okay, I'm gonna go back to this one. I just want to do the last two. Actually, no. Okay, that's fine. So find the coordinates of M, the midpoint of BC. So I want to find the midpoint of BC. So if I want to find the midpoint of BC, I'm gonna use the midpoint formula. So MP is equal to x1 plus x2 okay, so let's name this be x1 y1, let's name this x2 y2. So x1 plus x2, what is 2 plus 8? That's 10 divided by 2 is 5. What is 8 plus 12? That's 20. 20 divided by 2 is 10. So my midpoint is 5, 10. Perfect. Okay, AM. Find the median, find the length of median AM. So, okay, perfect. I know this is a median right here. And what was this median again? It was 5, 10. And this is 5, 4. Okay, perfect. So, if I want to find distance, right? Well, what type of segment is this distance? I mean, what type of distance am I going to use to calculate this segment? What type of segment is this? It's a vertical segment. How do I know it's a vertical segment? Because they have the same x coordinate. So do I need to make an invisible right triangle? No. I just need to use the formula. What's the only, guys, remember, for a vertical segment, what formula do we use for the distance? What's the only thing that's changing? My y coordinate. So I need to do absolute value of y2 minus y1. If it was horizontal, what's the only thing that's changing? My x. So I need to do x2 minus x1, absolute value. So now, what is 10 minus 4? That is 6. What's the absolute value of 6? 6. So my median is just 6. Okay. Now, if I want to find the centroid of P, So the centroid is where all the medians intersect. So I know that this median, the centroid is going to be at the 2/3 location, right? So this length of 6, correct? This length of 6, if I find 2/3 of 6, won't I be able to calculate where my centroid is? Because any segment, this segment, like let's say my point is somewhere here. This is going to be my 2/3 portion, and this will be my 1/3 portion. Why? Because I'm from the vertex to the supposed centroid, and from the supposed centroid to the midpoint of the opposite side. I know this is the midpoint because we already established that. So I just have to find where that centroid is going to be. So in order to do that, I need to calculate, excuse me. So I need to calculate how long is 2/3 of this entire segment. Well, I know that the entire segment is 6. So what is 2/3 of 6? Well, this turns to a 1, this turns to a 2. What is 2 times 2? 4. 1 times 1 is 1. So I need to go up 4 paces, 4 units in order to reach that 2/3 portion. So from here, I'm going to climb 1, 2, 3, 4. So where was it? 1, 2, 3, 4. So this is my supposed centroid. And it makes sense because how many paces is this? 1, 2, 3, 4. So this is 4 and this is 1, 2, 2. Now, let's see if this is actually 2/3. Is this 2/3 of the whole median? Yes, because the whole median is 6. And how much is 2/3? 4. This is 1/3. How much is 1/3 of 6? 2. So this is indeed my centroid. So my centroid, what's the location? It's 5, 8. And we can solve that pretty easily because if we went up 4, what do I have to do to this 4 down here? I just have to add 4 to it. So it's 5, 8. So this is another question that is tricky. So we can go over this one as well. So far we have 30 and 45 that are kind of tricky. I wonder if they'll be on your test. I don't know. Who knows? All right, so 5, 8. Okay, so in the diagram, last 2 questions, guys. We're almost done. In the diagram, RS and PT are altitudes. And the measure of angle Q is 52. Okay, so I'm going to start writing things as I read. So if RS and PT are altitudes, then I know that the intersection of RS and the intersection of PT is going to form 90 degrees. So where's RS? So RS is over here. So I know that this RS is going to be 90 and 90. This PT is going to be 90 and 90. And Q is 52. So Q is 52 degrees. Okay, what do they want to find? Let's put it in orange. They want the measure of SRQ. So SRQ. Okay, so they want this measure. Okay, well that's pretty easy now, right? You see how much easier it is when we actually solve it, like when we actually put in our information. I know that this angle R is just an angle in what triangle? This triangle. Let me highlight it. RSQ. Why is it so thick? Whoa. I think that's the smallest it goes. Okay, that's fine. Okay, so RSQ. So now this whole triangle, we could use the triangle angle sum theorem, right? I have 52 right here. 52 plus this 90 plus, let's call this x, equals 180. So this is 142 plus x equals 180 minus 142. X is equal to 38. So my x is equal to 38, and what's my 38? It's angle SRQ. 38. Okay? So Last one, very similar question. In the diagram, RS and PT are altitudes. Okay, so let's start doing that. RS and PT are altitudes. Notice how I'm doing the right angle both ways, just in case it's on a one triangle and not the other. So, okay. And Q is 51. So this is 51. Did I just do the same question twice? No, okay. Okay. Find the measure of OPS. So OPS, okay, so they want OPS, this one. Okay, so once again, look how much easier it is after we put in our information. You guys should be drawing this. So on your paper, you should be drawing, obviously because you can't write on it like I can. So on your paper, you should be trying to draw this triangle. Like that, and then you have that. You have S, P, O, R, T, Q. You know that this Q is 51. You know that you want this. Oh wow, look at my angle. It's just this. And now you can do triangle angle sum theorem. 51 plus 90 plus, let's call it X, is equal to 180. So we know that's going to be, I think it's 39. 39. Right there. Okay, so these last two questions are not hard if you just draw it. Okay, so once again, question 30, I think, and 45 are really tricky. So we can go over it in class. Please, I hope you guys do your homework so you can ask me which specific questions to go over during class. So we're done with the chapter 4 test review part 1. So good luck.